Welcome back. We're going to talk about turtle graphics here in a second. But before we do, one more thing about names, and that is our conventions for creating them. Okay? So when we're writing a name, we have to think up a name for an object. Those names can include letters, numbers, and underscores. Okay? No spaces, no punctuation, no weird symbols, just letters, numbers, and underscores. They have to start with a letter or an underscore. So you can't start a variable name with a number. Names are case sensitive. So for example, pi with both lowercase, pi with an uppercase p, and pi in all uppercase are all different names. Okay, and so we could conceivably have three variables named each of those, although that would be bad form to confuse ourselves like that. Names can't be keywords. So if you take a look at the keywords in table 1.4 in your chapter, it shows you things like for instance, that we used in our, we're going to be using in our for loop. You can't use that as a keyword. Okay, or def for defining functions. You can't use that in a variable either, okay? So you can't use the ones that are listed in table 1.4. This is maybe the hardest part. The names that we choose should be meaningful. So it should be immediately obvious when we read it what that variable stands for. So you may have noticed in the previous sessions, in the previous video, we had things like radius and height and base area. So those are good examples of variables that are named properly so that they're meaningful when we read them. Okay, lastly on variables, our convention is what's called camel case. So we'll always start variable names with a lowercase letter, and then if there's more than one word, every subsequent word has a capital letter in it, okay? And that helps us understand where the word breaks are. Now, as you go and work with Python, you'll find that that is not a universally accepted naming convention. And so other names that we encounter that are done by somebody else may have a different style, but this will be ours. All right. We're going to talk about abstraction, and our tool for this, again, is going to be Turtle Graphics. So abstraction, the book defines as a concept or an idea that's not associated with any specific instance. So like if you have a calculator, sine, cosine, and square root, those are abstractions in your calculator because they work for anything. Any number that you put in, you can take the sign of, for instance. Okay? So one of those functions is able to work for all numbers instead of having to have a different one for every number. Okay? And we're going to conceive of these functions as black boxes. That means it's opaque. We can't see through it. I don't know if you look at figure 1.8 in your book for the square root. We have the black box that represents square root. We put a number in. It does whatever it does. Magically, I don't really need to know how. And it gives me the square root of the number on the other side. Okay? And so the abstraction, we've been talking about it here for a while, so let's actually get to it, that we're going to use in this section is called Turtle Graphics. And in particular, we're going to be using a specific one, Colab Turtle, that's adapted for using in Google Colab. So there's tons of stuff that's already been written in Python for us. And it turns out, in fact, that part of mastering any programming language is learning what parts it already comes with and where to learn more about them. Okay, so think about, again, if we think about Python as our toolkit in general, Python just has tons and tons and tons of tools up on the wall on pegboards. And as you become a master craftsman, you learn to use those tools. And so that's what we're doing here, is we're starting to learn about some of the tools that come in Python. So a lot of these extra parts come in what are called modules. And to use those, then we have to use a statement like this: import module name. Okay, so in our next video then, we're actually going to get into examining Colab Turtle, and we will make Gertrude walk around on canvas and draw some different geometric figures for us.